Hello everyone and welcome to this tutorial on artificial intelligence and sentiment analysis in marketing. I'm thrilled to take you through an insightful project that promises to unravel the fascinating interplay between data science and marketing strategies. In today's fast-paced digital landscape, leveraging the potential of AI isn't just a choice, it's a necessity for businesses if they are aiming to stand out in the crowd. I'm Aslan. I specialize in data science, machine learning, data analysis, and mathematical modeling using programming languages such as Python, R, and MATLAB, and tools like Tableau and Excel. Imagine being able to tap into the thoughts and emotions of customers, giving a deep understanding of their opinion and reactions. Well, that's exactly what we are diving into with our comprehensive case study, Artificial Intelligence for Sentiment Analysis in Marketing. Our focus, Amazon customer reviews. Yes, the reviews that influence our buying decision and shapes our perspective. To achieve this, I will arm you with powerful tools like Python, libraries, Scikit-Learn, Matplotlib, and Seaborn. We are embarking on the expedition into the world of data analysis, data visualization, data transformation, and machine learning. So why you should join this case study, you may ask? Well, my mission is to teach you how to construct, train, evaluate, and deploy an AI model that predicts sentiments for Amazon customer reviews. After you have finished this tutorial, you will be equipped with the essential data science concepts that will not only give you a solid grip on sentiment analysis, but you can also add this data science project to your portfolio and create good impression during an interview. Before we dive in, I would love your support. Don't forget to like, comment, and subscribe to my channel for more amazing tips and tricks. Without wasting any time, let's work on sentimental analysis and enhance your data science journey. Let's talk about this project objectives, what you will learn in this tutorial. First, we will master Python libraries. I will teach you to develop proficiencies in using Python libraries such as Scikit-Learn, Matplotlib, Seaborn for data analysis, data visualization, and model development. Then we conduct thorough exploratory data analysis that will help you to explore and visualize data to uncover insights guiding further analysis and model development. Then we apply text pre-processing techniques, and we will understand the importance of data cleaning and text pre-processing in preparing textual data for analysis and modeling. Then we implement the vectorization. So basically you transform text data into suitable format for machine learning algorithm that will be input to the algorithm, so they can perform the calculations and actually build an AI model on that. Throughout this tutorial, I will give you key concepts and insights into data science, sentimental analysis, so you can get a comprehensive knowledge about data science and sentimental analysis in particular. Then we deploy AI models. You will acquire hands-on experience in training AI models using various algorithms, and then you evaluate their performance. And finally, you will create a fully functional sentimental analysis model which will demonstrate your proficiency in text pre-processing, feature extraction, and model training that will boost your data science portfolio projects. So first of all, let's talk about sentimental analysis. I will give you a brief overview. So sentimental analysis is often referred to as opinion mining. It is a powerful technique within the field of natural language processing, such as NLP. At its core, sentimental analysis involves teaching machines to understand and interpret human emotions and opinions expressed within the text data. By analyzing sentiments behind the words and phrases, AI model can classify a text as positive, negative, or neutral, thus providing variable insights into reputable attributes, feelings, and reactions. So how do we actually train an AI model for sentimental analysis? Actually, there's a number of steps that we'll perform, and then after performing those steps, we are actually able to train an AI model and deploy it. So the first step in any AI model training or any data science project is to actually collect the data. We will gather the labeled data set with text samples and sentimental labels. So exactly what it does, it means that we actually will have the textual data that will demonstrate some sentiment, like a review about a product or something, a comment or tweet about a brand or something like that. And then we will also have the label assigned to it, which also tells that this this tweet is actually a positive sentimental, this is actually a negative sentimental, or is it a neutral sentimental. So after we have actually collected the data, we have labeled data, which is like either this data is either marked as positive or negative. Then we will move on to the next step, which is actually text pre-processing, where we clean the text by removing punctuation, special characters, lowercase conversions. And then we will tokenize our data, where we will like break text into smaller units like words. And finally we will move towards feature extraction, where we convert tokens into numerical representation using techniques like TF-IDF. We will further discuss that as we go down in this tutorial, and like where we reach our discuss feature extraction. So don't bother by it right now. Then we move on to the model selection. We will choose an algorithm that is best for our AI model training. Then we have finally actually trained the model on label data to learn sentimental patterns. Finally, we will evaluate the trained model based on performance metrics such as accuracy, precision, F1 scores. And finally, after we have trained our model and we are satisfied with its performance, then we actually deploy the model to predict sentiment in new text data. So this is how actually we train a sentimental analysis AI models. So now you have a good understanding of sentimental analysis. Let's briefly touch what does sentimental analysis mean in the context of marketing. Well, sentimental analysis is vital for business to understand customer opinions. It characterizes the text sentiment as a positive, negative, or neutral. In marketing, it helps gauge customer sentiment, refine strategies, and improve experiences. Extracting sentiments from Amazon reviews aids feedback response, enhancing customer engagement, impacting business growth. So let's talk about data. So this data source has been taken by the following link. You can actually go to the link and further export the data sets. So our data set comprises nearly 3,000 customer reviews of Amazon Alexa products such as Echo Doors, Alexa Fire Sticks. It encompasses essential columns that provide a comprehensive view of customer sentiments and opinion. In our data set, we will have like a first column, which is actually the rating. The column denotes the star given by customers, the star rating given by customers, okay, reflecting their overall satisfaction with the product. Then we have the date the review was given, which will further allow us to analyze sentiment trends over time. Then we have the variation. This column specifies the product variant being received, providing insights into sentiments variation across different product models. There are number of different products model, and which categorizes, okay, this review has been given to this product or this category of product. Then we have the most important column, which is the verified reviews. This review text itself contains valuable textual data that we will analyze to predict sentiments. So based on this textual data, we will actually predict which models, like which review is actually positive review and negative review. So this is actually a training data where we put actually to the trained model. And finally, we will have further one more aspect of the training data will be our feedback or sentiments, either 0 and 1. The sentiment label assigned to each view, whether 0 represents a negative sentiment and 1 indicates a positive sentiment. This binary classification will help our target valuable for training our AI model. So now you have a good understanding of our data, that we have rating, and the most important like that we have verified reviews and we have feedback or sentiment, whether the review was either positive sentiment or it's negative sentiment. So this is the core or basic of our training model. This like we will put input reviews and along with the feedback or sentiment, which will be our target variable, then we will train our AI model. Let's talk about now importing essential libraries before we actually start moving on working on our data. So we will start by some common and basic Python libraries that includes pandas, numpy, Seaborn, and Matplotlib. Visualization tools for creating insightful data representation. Seaborn offers simplicity while Matplotlib provides flexibility. Then we move on to importing libraries for text preprocessing such as NLTK, Natural Language Toolkit, which offers the text preprocessing tools like stop words removal, cleaning textual data before model training. Then we will import string and word cloud, which facilitates text processing and visualization. Word cloud generates visually appealing word representation. And finally, we will import vectorizer, which converts data into numeric vectors, which is crucial for model training. And after that, I will import data splitting and model training libraries, split, test, split, a train, test, split, which actually splits the data into training and testing. Then we will import our AI model that we actually train on. First one is logistic regression. The second one is like multinomial Navis Bayes. So these are the two models that we are going to train in our tutorial. Then finally, we'll import some libraries for the performance matrix calculation, such as precision, recall, F1 score, and libraries to actually calculate and plot confusion matrix. And now we will calculate detail about confusion matrix in the end of this tutorial. So this is the cell block where we import all the important and essential libraries. First one is like data analysis, visualization, or pandas, numpy, the common libraries. Then the second one is text processing in libraries. Then the third one is for data splitting and model training. And finally, by the use of model library Scikit-Learn, we will import essential model evaluation matrices such as accuracy, precision, and then finally calculation of matrices. Okay. So after we have imported our data sets, libraries, we will first now move on to actually import our data set. For this purpose, we will use the panda and the function read_csv, and for the input argument, we will define the actual path to the file name. In this case, we have Amazon_reviews. And in order to view our data set, we will use this function df.head, and which actually shows the first few rows of the data set. Where we have put 5 means that we only want interested in only seeing the first 5 rows of our data set. If you want to see further rows, like instead of 5 into 10 or 20, you can like change the value of 5 to 10 or 20, whatever suits you. So this is the data set we have. We actually have the column named rating, which is actually the star rating. Then we have date, where the review was actually given. Then we have the variation of the products, so charcoal, fabric, walnut finish, and other thing. Then we have our important features column, verified reviews, where customer actually have given reviews to the product. Then we have the sentiment associated with those reviews, that whether this review is a positive review or whether it is a negative review. So we have imported our data set. Let's move on to the first stage. Like we actually want to briefly inspect our data, what is in it, what's in there, and what is the data type, and much more. For this purpose, we will use df.info to get the key details about the data sets, like data types, non-null counts, memory usage. This gives us a basic understanding of the data structure and content. So we are using df.info method, and we can actually get after like using this function, we have actually all the columns here and their names. Then we have the total number of entities, like the rows that are present in a data set. Then we have the data type for each column, and like non-null values that are present in that column. So after that, we will just use a simple for loop to actually print some of the reviews of the data set. So we have seen something like that. Okay, review 1 is love Mike or love it. Sometimes while playing a game, you can answer quite correctly, and then blah blah blah. You get the idea. And I had a lot of fun with it. And the last one is like music. Like he doesn't bother to give anything else, like just to give one word, that is music. So after like we have inspected the data, let's move on to the stage where we actually pre-process the data. Pre-process stage is different from text pre-processing, and data pre-processing is somewhere like some data pre-processing, data wrangling, data cleansing. They all lie somewhere into the same context, where data wrangling incorporates more step as compared to the other two. But the context is, as I'm saying, that we need to do some operations on our data set, so it might be ready to further investigate our data or perform any data analysis. So the first one we would like to do is to actually check the null values on data set. So this is important because null values can affect analysis and model performance. For this purpose, we will assign a variable null_mask, and then we will use the function isNull, which actually creates a creates an index of all the null values that are present in data set. Then we will use some function that will actually calculate the sum of all null values that are present in a single column individually, and then we sum it again in order to collectively sum all the values of the column, and which will give us a collective all values of indexes or the counts of null values that are present. Then we finally print this value, and then we can actually see that the number of null values is actually 0. It means that there's no null value present in it. So we are good to go further with our data analysis. So for our data analysis, we will start with exploratory data analysis. So exploratory data analysis is a crucial phase in our data science journey. It helps us uncover insights and pattern hidden in our data sets. Exploratory data analysis involves calculations and visualizations that provide valuable information guiding subsequent analysis and model development. So the first one we will looking at is called summary statistics. So we basically are more interested in like what is the statistical distribution of the data here, and we will use the function df.describe, which actually and only incorporates those columns in our data set which has an actual numeric value. In our case, it is our first one is the rating, the second one is feedback. Feedback column itself is a categorical data. I mean, it doesn't have possess any numerical context into it, because we have actually 0 or 1 value that categorize either the views is positive or negative. So we will leave that. The important matters to look at is actually the rating. So the first one is count. We actually see that we have 3150 entities in the rating, and then we have a mean value. The average value of rating for all the views is actually 4.46. Then we have a standard deviation of 1.06. The minimum value is actually 1. So this is a quite good finding. Actually, there are some customers which actually had given this product a rating of 1, which means that you may want to develop more the why customers. Some customers have actually given 1 rating. What is the percentage of customers that actually have given 1 rating? And okay, and then we have a maximum value. Maximum value again is the 5-star rating. And but one other important aspect of this table is here, like we have actually quartile values, the 25%, 50%, and 75%. When we look at, for example, let's talk about 25% quartile, which is actually the value is actually 4. Which what does it means by that? 25% of the values in the dataset column rating is actually below 4. So that's what it means by. So it gives us a kind of sense of distribution in the mind. Although we can graphically visualize it through histogram distribution, or maybe a plot would be a better aesthetic thing, or present a better picture. But in order to like actually look at it, so this is how it is. Okay, 25% control. And after like giving us summary statistics, we will first move on to the distribution of sentiments. Like we actually want to count values, like how many views are actually positive and how many views are actually negative. So for this purpose, we will use this sentiment count underscore count. We will assign a variable. Then we call our data frame df. Then we call the specific column that we want to perform our operation, that is feedback. Then we perform this function, apply this function, which is value count, which actually counts the total number of zeros and ones in it. Okay, so this is how it does it counts, and I can see that the number of positive views has a highest value and more greater value. Actually, it is more than like 10% over the total value. I mean, approximately. So you get the idea here, and you can see that there are 2893 reviews are actually positive, and while negative reviews are 275. After we have studied the distribution of sentiment, let's study the distribution of rating. So rating, like okay, we have a rating of like from 1 to 5. Actually the products are rated, so we actually want to see okay how many reviews are actually rated 1, how many reviews are actually rated 2, and up to the 5. So after we have done, and we will follow the same methodology. First we assign a variable, then we call our df function, data frame, then we call the specific column, and then we use the value count, and then we will store these values from rating by rating wise. Okay, so it's not by like the value, actually it's by rating. So 1 2 3 4 5 is actually by rating wise, not by the actual value that is present in it. So after analyzing, we do see that okay 161 products have been actually rated as 1 or couldn't demonstrate bad, and then we have 2, then we have 3 and 4, and finally 5, and most majority of the like products have been rated as 5, and this is quite close to the actual positive sentiment here. So you can see it here as the positive sentiment. And after that, we want to like study the distribution of variations. You understand that this data set has reviews of various types of products. and we want to study its distribution, like how many times a specific product has been reviewed, and how many times like the specific product is reviewed. So we can do this by doing the same methodology. First we will assign a variable variation underscore counts, then we like call the data frame, then specific column, then we use value count, and it will display the values like from the highest item that has been reviewed to the lowest value atom that has been reviewed. And one like important study, so it is give us an idea, okay, like black dot, charcoal fabric, configuration T5 are the most sold out product, they are most reviewed product, that customers have more positive or negative sentiment towards this, and based on this data marketers and strategies can also align their marketing strategy accordingly. So these are the products that are more bought frequently. And another important aspect here, like you can study and you can do it by on spare time. You can actually use group by function and actually see whatever the method you would like to adopt, we will actually see, okay, out of this black dot, let's take the example of top 10 variations the customers have reviewed. We would actually like be interesting to know, okay, how many products are reviewed positively and how many products are reviewed negatively. So this is kind of a different context, like the sentimental analysis. It is more related to the exploratory data analysis. So it will give us a better picture. Okay, we might be able to identify any outlier that this product has been performing badly and it's affecting the overall response rate of others product, and or it could be that the bad reviews are distributed randomly or evenly, something like that. So this is another important study. If you want to do it, you can conduct it by any methods you would like. So right now we have like conducted the exploratory data analysis. Now we will move towards the data visualization part. Visualizing data is a powerful way to gain insights, find patterns, and communicate complex information in a simple manner. In this section, we will use data visualization to explore Amazon reviews datasets and understand its for better. So it will also help you like to better pitch a data story to stakeholder. Or maybe a stakeholder is a marketing manager, or maybe a stakeholder is a investor or something like that. So you get the idea. And for those of you people who are actually interested more in this data visualization field, and there is actually a tool called Tableau that is specifically designed in order to plot various data visualization and without the help of any need of code. And if you actually into that data visualization code, I actually have a highly comprehensive and detailed tutorial on Tableau. We will teach from the basic, from like actually making an account or Tableau public, from understanding Tableau visualization and its interface, then actually plotting simple plots to have more complex plots on Tableau. So I will like post the link in the description, and I will also leave the link in somewhere on the video. So if you are already interested in that kind of thing, go check out that video. It's highly resourceful and learn the Tableau, right, and enhance your skill as a data scientist. So first of all, let's visually distribute distribution of sentiments. Like we actually want to see graphically. For this purpose, we will use this generic plotting notations, and we will use a Seaborn library, and we'll pass the input as feedback column from the DF data frame. And we will label the zeros and one as negative and positive. Now you see this is a more better representation of the distribution of sentiments as compared to just the numerical value, which can now it's give us a more vivid picture of distribution of sentiments in our data sets. So when we see very minute amount of that is have been sentimented as negative, while the rest is either positive. Now let's graphically visualize the distribution of rating, and we will follow the same notation and pass the input argument as rating column. And we see that majority of the products are actually rated as 5. And let's do the same for distribution of variations. So remember that there are number of variety of 5 products, number of varying products in the data set that have been reviewed and segmented as positive or negative. So we want to actually see graphically. So we follow the same notation, and we will pass input argument variation of the data frame DF. and we will show the values here, and this is a more better representation than it gives us a more contextual and relationship how this value is relating to the other one, like the other product. So we see the black dot has the highest value, then charcoal fabric, and as you go on to the lowest one, that is ball and finish. And like after doing that, we like to study the distribution of review lengths. What do we mean by review length? So we have actually a review for a product, and it contains some characters. So we will actually like to see what is the probability or what is the frequency of most frequent occurrence of reviews length. Like the customer would like actually most of the customer somewhere would like to give a review of a particular length. So we will you plot it through histogram. And in order to plot the histogram, we will use plot.hist. We will pass call the data frame, then give the review length as an input argument. But how do we actually calculate the review length? We will use a simple notation. First of all, we will assign a new column in our data frame by calling df data frame and giving the column a new column name. In our case is review length. Then we will assign it to the value there on a column we actually want to perform. But basically it is okay, we are taking verified reviews, then applying operation that will calculate its length, then putting those length values back to the new column that we have just introduced here, use_length. So it had calculated length. Now we are after we have calculated the review length, we are actually giving it as an input argument. Then we are defining the bins, what is the interval of data points, and then alpha is just for the transparency. And after plotting that, we can actually see the customers that have reviewed these products, the length of the characters somewhere ranges from 0 to, as we go on to the maximum, most of the time 500, then 1000. And we actually do see there are some products which have been reviewed between 2000 to 2500. I mean, they don't have any else to do in their lives, so that's why they give us so much a big review. So anyways, so this is the distribution, and we can actually see the majority of the comments in the range of 0 to 300. So or 250. The majority of reviews that have been received actually has a character length of between 0 to 250. So now let's plot an amazing thing which actually help us visualize what are the different words that have been used in the reviews, and we can do it for all the reviews, and we can do it for the positive and negative reviews. So how we do it? We do it by visualizing textual insight through word cloud. So in this data exploration phase, we will use word cloud to actually visualize the text. Word clouds help us see the most common words in our Amazon review datasets. Word clouds are great for showing insight visually. They help us see the main topics by showing the most frequent words. We will make separate words for cloud for positive and negative reviews, and we can see that the details shape customers' opinion. These visualizations help us understand the sentiments better, which guides our future analysis. So how do we actually make a word cloud? So let's go directly go to this code cell here. In order to create the word cloud, we actually do have to join all the reviews of all the rows and into a single paragraph, for example. So, and how do we do that? We actually use the function join, and then we call the respective column, that is verified reviews. And after we have joined all the reviews here, we are using actually the word cloud function here, and this one, and then we are actually defining width and height, then background color, and then we are passing the input argument all reviews. And then finally we will plot it by using simple plotting notation. We have our word cloud here, and interpolation would be bilinear, and by following these steps we actually have created a word cloud, as you can see here. And this gives us a very more good insight into our data set. Okay, what kind of words have customers are used more often? Love is the highest time. Then Alexa is also used. Use, great, device. I mean, this indicates that these are more often words that have customers has used in their reviews. Then we have music, work, time, speaker, set, one. all is that. Now after like generating the word cloud, now you're more interesting like generating the word cloud for positive reviews and negative reviews. So how we are doing that? So we actually have to actually take out all the reviews that has a positive sentiment label to it, then we have to take all the reviews that has a negative sentiment label to it, and we are doing it here in these two line of codes here. So for the positive review, we actually is using the same function as we had done earlier, that is df join. Then we are actually first creating a mask, then using that mask we are only taking the values from verified reviews. The mask is created by like df feedback. Feedback, remember, is the sentiment that has a values 1 or 0 or positive or negative. So we are actually creating a mask that we are telling that okay, we only want interesting the values that has a sentiment is equal to 1, and only extract those values from where verified reviews. So that's how we are only collect the values of positive review. And the same way that we have collected the values of negative reviews, where the feedback is equal to 0 only. And after having done that, we will follow the same process here. We will use the function word cloud. We will give all the necessary details, pass the input argument, and then we will use the generic plotting notation. So we will have like this is for the whole words, and this is for the negative sentiment reviews, this is for the positive sentiment reviews. So it's quite interesting to look at. Okay, for the negative we see that people more often use like okay, work, device, Amazon, Alexa, time, echo, dot, screen, or could be the thing that okay, the screen is an issue for them. And for the positive we use as they okay, the first one is like love, we love this product, we use that created echo. So this is the more of a contextual insight into positive or negative. Up till right now you have done all the preliminary data analysis techniques. Now let's move on to actually creating an AI model. For this purpose, we will first begin by text preprocessing in sentimental analysis. Text preprocessing is a crucial step in sentimental analysis where we prepare raw textual data for effective machine learning analysis. This process involves several key tasks for all like the tokenization, like where you break text into individual words or phrases, making analysis easier. Then we have punctuation removal and lowercasing, removing punctuation marks and converting text into lowercase for consistent analysis. Then we have stop word removal, like removing common uninformative words to focus on meaningful content. Finally, we will have stemming, which is like reducing words to their root form to treat variation as the same word. We will discuss that more as we look at the function here. Like after like you have applied all these steps, the preprocessed text becomes the foundation of feature extraction and sentimental analysis. Feature extraction, like okay, when you actually convert that textual data into numeric form, so we can feed that into AI model. So if you look at this thing, text preprocessing phase, the first one is actually we have like tokenized the words where we split the paragraph or a sentence into or anything into words. Now after we have split that, we actually converted into lowercase and we have removed punctuation by the use of translate, and where it's actually iterates over each word, and it will look for the certain punctuations, all the punctuation that are present, and if there is a punctuation present, it will be removed. And after that we will use the remove the stop words. Stop words are actually the words that actually don't contribute to the context of the meaning, and in order to do that we are using the function here stop words dot words, and we passing the input argument English, because the stop word we have using in this analysis actually the reviews are in English language. So the dot words like the, and these words don't contribute to the actual context Tableau. So after we have removed the stop words, we will do the process called stemming, where we reduce the words to their root form, and for this purpose we will use the function porter stemmer, and we will pass the input argument by using a for loop, and finally we will reconstruct preprocessed text. I mean like whatever the words there remain after pre-processing, we will like combine them back into a sentence, and then we return it outside of the function. So we have actually created a function for all these steps, and after we have created the function, how will this function perform? This is a quite good answer. Well, what we will do, like we will actually take one by one, or I mean the context to get just to give you the context, we will extract value of a row from the verified views where the actual views are present. Then we will apply this function pre-processed text, which will actually pre-process the text and returns it back as a like we will actually process the text and return it back as a pre-processed text. And after like we have done the operation, we will like to store it somewhere. So for this purpose, we are actually creating a new column that is called pre-processed views. So this is like, okay, we have applied the operation or view, and then we are storing it in the column pre-processed view. So this is how we will perform text pre-processing. After we have done the text pre-processing, we are good to go to the next phase, which is actually the feature extraction using TF-IDF in sentimental analysis. Well, in sentimental analysis, feature extraction is a crucial step that converts processed text data into number suitable for machine learning. One common technique is TF-IDF, term frequency inverse document frequency, which assigns weights to the word in text document. It measures words important within a document while considering its frequency across all documents. So what is actually TF-IDF, you may ask? Well, again, it is a romantic representation that gives weight to the word based on the occurrence in a set of text document. It quantifies the word importance in a specific document while considering its rarity across all documents. This technique captures word significance in individual documents within the entire corpus. So you get the idea. Then I also like to see why we are using TF-IDF for this sentiment analysis. First, it actually gives the word importance where it considers word frequency in a document. Then it also gives the contextual relevance to the word. Then it will also perform dimensionality reduction by controlling the number of features words using techniques like max features. So TF-IDF reduces data dimension. This enhances efficiencies and help identify key features that impact sentiment. So how actually we like incorporate TF-IDF and how we perform the vectorization? Well, we'll do it by this set of code lines in a cell. So we are using the function TF-IDF vectorizer. Then we are passing the input argument max feature is equal to 100. You can adjust this max feature as you need it. After you have done that, then we will create a generic assigner, then we are like to give assignment. Then we assign a variable x for like generic purpose. Okay, this is the training feature that we will input to the data set. Then we are using the fit transform. Then we are calling the actual values from which we want to perform the vectorization. In this case, this is our pre-processed reviews column. And then we finally are converting into an array form. So after we have done that, you can actually use this for loop to actually visualize some of the values here, as you can see. And after that, like after we have like text perform feature extraction, let's move on to the next phase, which is actually the model selection and training in sentimental analysis. In the domain of sentimental analysis, model selection and training form the bedrock of transforming our pre-processed text data into predictive insights. These steps involve choosing suitable machine learning algorithms and training them to accurately classify sentiments in customer reviews. The model employed in this project are logistic regression and multinomial naive Bayes and their sequences in segmental analysis. So first of all, let's talk about logistic regression. Logistic regression is a classic binary classification algorithm employed in sentimental analysis. It operates by learning a linear relationship between the input features and the likelihood of certain outcome. In our case, it would be either positive or negative sentiments. And for the multinomial naive Bayes, is actually another powerful classification algorithm. It's well suited for text classification tasks due to its simplicity and effectiveness. Naive Bayes calculates the probability of a particular sentiment given the presence of certain words. Despite its naive assumption of independence between features, naive Bayes often performs well in practices. The multinomial NB function from the Scikit-Learn is used to train the multinomial naive Bayes model. So how we actually do that? First, we need to actually split the data into training and testing. For this purpose, we are actually using train test split function, and we are passing the input argument. First is the x and the y, second is y. What is y? Y is actually the prediction value or the target value that we want to predict. In our case, it's the sentiments either 0 and 1. Then we specify the size. that we want to split the data when we set it to be 0.2 or 20%. It means that 20% of the data is actually given to testing data, and the remaining 80% of the data is actually for training data. And after we have done that, let's move on to actually training the model with our given data set. So we are actually have created a function here which will take the input argument X-Train, which are the vectorized feature extracted features of textual data. Y-Train is actually the sentiment 0 and 1. Then it contains the model type. We have two model types. First one is logistic regression and the second one is multinomial NP. So and after that we are using the function here model fit to actually train the model. So first of we are calculating it for logistic regression. The second one we are calculating for multinomial naive Bayes. After we have train our model here, we want to evaluate its performance by using evaluation matrices, and we are using accuracy, precision, recall, and F1 score. When we talk about accuracy tells us how correct our model predictions are, and for precision focus on accurate positive prediction in the ratio of 2 positive prediction to all positive prediction. High precision means reliable positive prediction. Recall measures the model ability to correctly capture all positive instances. It's the ratio of the 2 positive prediction to the actual positive instance. And F1 score, which is actually the balances between precision and recall. It provides a single matrix that considers both aspects. It's useful when dealing with imbalanced classes. So if you recall that we in the beginning where we have imported libraries, we actually use a scikit matrix to import all the performance matrix calculation and functions. So we have actually created a function here, evaluate model prediction, and in that this function contains and takes in 3 input arguments. First all is the trained model. We have 2 model, logistic regression and multinomial NP. Then we takes the testing data. Remember that we actually split the data, and we have actually 20% of the data is actually retained to testing it. So this is the we have testing data here, X-Text. Then we have the actual testing sentiment, what is the actual sentiment of these things. So we will use model.predict to actually calculate the prediction based on our X-Text. And then after we have calculated the prediction, then we use only 2 quantities to calculate all the performance matrices, that is predicted value of sentiments and the actual value of sentiments. We will pass it to the accuracy score, we will pass it to the precision score, we will pass it to the recall score, and finally to the F1 score. This function then finally returns all those values. And in this line of code, these 2 lines of code, we actually have given different assignment names for each model, for the logistic regression and naive Bayes, and the function is applied to both of them is actually the same. And while the input argument for the logistic regression is actually logistic regression model we have actually trained in the previous test, and for the second one is multinomial NP model. This is also we have trained in the previous step here. So after we have done all those things, we actually are good to go to perform evaluation matrix and actually see which model actually have performed better. After running this code, we actually see these values tend not to be differ a lot. So we actually see these both models have actually performed better, or they both of the models performance is equal in terms of the when we see it by performance matrix. Now let's move on to the other aspects by how we can actually graphically visualize a model evaluation. So in order to do that, we will be using visualizing model performance with confusion matrix. Confusion matrix is a vital tool for evaluating model. It gives us a clear view of how well a classification model performs. It breaks down the prediction into 4 categories: true positive, true negative, false positive, false negative. These categories helps assesses the model effectiveness. So first one is we would like to know what is actually confusion matrix. Okay, so confusion matrix is a table that summarizes classification results, and it shows the model prediction in a structured way, making it easy to evaluate its performance. Using the plot, we will use this function here called plot confusion matrix. So how does it perform? First of all, it calculates the model prediction as we have done earlier in the evaluation matrix. Then it generates the confusion matrix using Scikit-Learn's confusion underscore matrix function. Then it labels 0, 1 represents into negative and positive. Finally, it visualizes those matrices by the help of this function confusion matrix display, and then relabels the positive and negative zeros and 1 as positive and negative for clarity. So this is actually the function. Okay, first of all, this function actually takes four input arguments. The first one is the model, the logistic regression on email bias. The second one is actually the text features. Then the third one is actually the actual sentiment that is assigned to those features. Then the title. So we are using like confusion matrix function. Like after we have calculated the predicted values, then we plot the confusion matrix, calculate the confusion matrix by using this function here and passing input arguments, which are actually the actual values, then the predicted values by the model. Okay, and when we'll pass input argument, will label it as 0 and 1. After we have calculated the confusion matrix, we will actually use this function confusion matrix display to actually graphically visualize the confusion matrix. And we are using this function for both logistic regression and multinomial to actually calculate and plot the confusion matrix. Okay, so we have like here confusion matrix for logistic regression confusion matrix, then multinomial naive Bayes confusion matrix, and we can look at this and I will explain to you what does it means here. So first of all, on the x-axis we have predictive label, on the y-axis we have true label. So what does the y-axis mean? That it tells you, okay, these are the actual values, and predicted label actually tells you what are the values that have been predicted by our models. So if you look at this thing and if you see here, okay, let's talk about positive. So here it says this is the true label. Like if you this thing, the first row, the second row is for positive and the first row is for negative for two labels, and the same thing goes for column. The first column is for negative and the second column is for positive for predicted label. So the diagonal values here, this is the first, this one, and this one, the diagonal value here, blue color, actually are the ideal presentation. They must be like some more values as compared to this one. This is the the false prediction, and we tend to build a model that has a very few or less zero values. And as you can see that actually our model has predicted quite well for positive sentiments. As you can see that here, the true label, this is the column raw for positive values, and we can also see that the column for positive, this here has the highest value, 572 reviews that were actually positive were also predicted by a model as positive. But when we comes to study the same thing for negative, we can see that our model hasn't performed well. In fact, has performed bad. There could be a multiple of reasons. Like first one could be that the data set is quite not big for the negative reviews. That's why it has predicted bad. Or there could be another factors. But for right now, we are only interested in this confusion matrix. So for the true label, we actually see what does it tells. Okay. For the true label negative, we see that actually only one value that was actually negative, has a negative sentiment, was also predicted by our model as negative. But there were 57 values that were actually negative. Okay, there are 57 values that were actually negative, but they are predicted by our model as positive. So this is the thing, which identifies, okay, on this stage for negative views, our model has not performed accurately, but it's giving a bad prediction. And if you go and look at the same thing for multinomial naive Bayes fusion matrix, we do see the same trend. But for right now, we actually see we have like 57 to positive values, and we have one the same way we have 1 and 57. So get the idea here, okay? So this is how like we perform sentiment analysis in marketing. And we have like, actually if you go back and recall it, we have actually in the first phase we have actually imported the important libraries. Then in the second phase we have imported our data set. Then we inspected the data and check it whether there is a null value present in it. After like performing the data pre-processing, we perform exploratory data analysis, and we graphically visualize some of the distributions of data, and just like the reviews length, sentiments, and etc. And after like that, we move on to actually building an AI model. For this purpose, we first perform text pre-processing, where like we have used all the important libraries that are required in order to perform the text pre-processing. After performing the text pre-processing, we conducted feature extraction, where we have converted the textual data into numerical values without done vectorization. After we have done that, we have used two regression model, two AI model. First one is logistic regression, the second one is multinomial naive Bayes. And after like we have trained the data for these two models, we actually evaluated their performance using performance metrics such as precision, accuracy, F1 score. And after we have evaluated the metrics models based on performance metrics, we have actually plotted confusion matrix plot. And we identified that okay, our model has predicted well and good for positive reviews, but it doesn't predict it well for negative reviews. So we may and want to further investigate it, maybe optimize our model, maybe include further more data sets that has more or less equally values for negative reviews, like somewhere like around 3000 values for negative reviews, so our model can train well on negative reviews. So that's it for now. I hope you like this tutorial. And again, if you like into data visualization, I have a very highly resourceful video. Go check out that video. I will take you from the beginning, where I actually teach you how to set up an account, then I will teach you about the interference of Tableau. Then finally I will teach you how to plot in Tableau from scatter plots, then plotting a trend line, then plotting donut charts and donut chart. So this is a highly resourceful, but I must suggest you go and check out that video. I have another video where I predicted real estate prices using deep learning. So I will also put the link in the description for you. And if you like this video, don't forget to like, comment, subscribe to my channel. By doing so, you will be the first one to know about latest tips and tricks. And furthermore, it will also help me and support me to make more videos like this. That's it for now, and I will catch you soon in the next one.